Here you go, the first look of our LLM playground looks nice and clean. Let's say a hi, and then let's say, can you write an essay of 200 words on AI? And there you go, we are getting our response as a stream. And let's use Llama 3.2 1B, and right here. Hello guys, in this video we'll build our own LLM playground with Tauri 2.0 using Rust. In this video, we'll be using Tauri for cross-platform development. Precisely, we'll focus on desktop development in this video. But I've covered it for iOS, Android, and desktop development in previous videos on my YouTube channel. Should be popping somewhere on right top. If you're new to Tauri, I highly recommend you guys to watch that videos before moving on to this one. And we'll be using Ollama to serve our models, React for frontend of our desktop app, and Rust for business logic. So without further ado, let's dive into it and let's begin. And as we start, there is a link to my Discord in description. Make sure you join it. First of all, let's add our Tauri project. So I'll be using Yarn as a package manager in this video. You can use npm yarn pnpm bun, but if you want to use Yarn and it's not already installed on your machine, I've dropped a link to the installation guide in the description. So just follow it, and then we'll just do yarn create Tauri app and the name of the app. So I'll name this as LLM playground com.llmplayground.app as the identifier, and language for frontend JavaScript and TypeScript, package manager as Yarn, but you can use either of these, and we'll be using React for UI and UI flavor as TypeScript. So that's it, we have our project ready. So now let's move to our LLM playground. And once we are in our LLM playground, as you can see, we have default Tauri skeleton for our project. Now one last thing before we start coding is we need Tauri apps CLI. So let's quickly add it. Yarn add Tauri apps CLI. So once we have apps CLI on our machine, now we can move to our favorite IDE or text editor. So this is the cargo terminal we have from our generated project. Now we need a few dependencies here, so let's quickly add it. The first dependency that we need is Tokyo. So cargo add Tokyo, and then we need futures util. So cargo add futures util. And the final one we need is Ollama RS. So cargo add Ollama RS. And here we need feature as stream. So we have our dependencies ready. And right here, let's simply reload. We have our dependencies ready. Now let's move to our librs. And here we'll add our Tauri commands to kind of add our business logic. First of all, let's add an app state to share our Ollama client across multiple commands. So struct app state Ollama and mutex from all the way Tokyo, and pass our Ollama, and right here we'll just do manage and pass our app state and Ollama mutex new Ollama and default. So we have our app state pass. Now let's add a few struct that we need. The first one that we need is chat request and chat response. So chat response and derive serialize. This is something that will pass to the UI message, and struct chat request as model as string. And another thing that we need is messages as vector of chat message. Derive deserialize. So this is all the structs that we need. Now let's quickly fetch our models. So async fn get models as our first command, state and app state, and return result vector of string or string as our response. And now let's fetch the models. So let client is equals to state olama lock await get the client, and client dot list lock local models await map error e format, and we'll just say fail to list models, and if we get it, then we can simply do is models iter map and dot, you can see we have name, modified it or size. I'll just stick with name for now, and clone and collect. That gives us our get models, which is our first Tauri command. So let's add Tauri command on the top, and let's pass get models right here. Get models. Similarly, let's add chat, where we'll also be using our channels. So channels I have covered in detail in some previous videos, should be popping somewhere on right top. Here we'll just use it. Basically, we can use channels to update our front end from Rust, and it's very helpful for such use cases when we stream our response to our front end, or for example progress or loading, something like that. So we have our request, which is the chat request. Then we have our on stream, which is the channel that we have. As you can see, Tauri IPC channel, and the response that we want to send is chat response, and state as state. So let's pass our app state. So that's pretty much all the things that we need. And result of unit string let mutable client state olama lock await chat request chat message request and new. So right here we will pass our request dot model, which we get from the front end, and then we also pass our messages, which is all the message that we have. And once we pass that, we'll just say let mutable stream is client dot send chat message stream, pass the chat request that we have, and await. Again, let's map the error e format fail to start chat string. And then we'll just stream our response while let some response stream next from future utils await. So that's why we add future utils, because we want to use next from here. So right here we await, and then let response is equals to response dot map error. And just to be transparent, we are formatting all the errors. Stream error. So then we'll just do is chat response message as response.message.content. And once we get our some chat response, we'll just use onStream.send and chat response.map error to string. And finally, at the end, we can just return with OK of unit. And let's move on the top here. Let's add Tauri command. And all the way down, we'll just expose this as well. So that's pretty much for our second command as well. Now, for this specific video, I'll just stick with these two commands where we have get models and chat. But I would highly recommend just exhaust all of this SDK on your front end. You can also have pull model, push models, and other commands as well. Even function calling as well, which we have covered in separate video, but we are not adding on the UI today. So yeah, all of these are our commands, and let's make a fancy front end for this to serve our commands on our LLM playground. Let's move to the front end side and add our React code. So in our project, we need a chat component CSS and chat component TSX. So first of all, let's add our React component. First of all, let's add a few types that we need. Chat message, role as string, content as string, and then we need chat response, message as string, and then our functional component. So const chat component react fc and we don't have any props for this component. So at the end, we'll just export our component chat component, and let's write it. And let's move to app.tsx, our basic component. So let's finish this up first. Const app react fc, again no props, and same way we'll just export default app, and right here we'll just return main and last name as app container, and then we have a div. We all love divs, and we class name as playground card, let's say, and then we have an h1 that says LLM playground. You can name it as you want, and then class name as title. That is our title, and then we have our chat component, which we just consume here. That's pretty much all for our this component that we have. And let's import React from React, and the next thing that we need is import app.css, which we'll just add in a minute. So we have our app tsx ready. Now let's move back to chat component tsx and complete this. Let's quickly add a few states that we need. Const messages, set messages, use state. So this is our chat message, and an array to store the messages initially as an empty array. And then we have is input, set input, and use state. This is the query that the user types. And then we have is const models, set models, use state, string array, and initially as an empty array. And then we have selected model, set selected model. So this is the one that user prefers to use for the query. Remember, we'll design it in such a way that on fly users can change the model. And we have our set models. Similarly, let's first add the UI part. So use effect, and this one we need to load the model as soon as the component mounts. So const fetch models async and try const fetched models, and we'll use Tauri command here, invoke. So this should be the same name as your command in Rust, get model. Remember, invoke from Tauri apps API core. So we have our get models, and once we have the models, we'll just do set models and pass our fetched models. And if fetched models dot length is greater than 0, then we initially select the first one as the first model, fetched model of 0 as the initially selected model. And similarly, we have a catch block, and right here we'll catch any error, and if there is any error, then we simply do is console error failed to fetch models error. So we have our try catch, and we have our function which is fetch models. So fetch models and dependency as empty. So this right here is our use effect for fetch models. And now similarly, const send message async form event promise void, and right here we'll just do e.prevent default to prevent the UI behavior, and input.trim or no selected model. If the input is empty or no model is selected, then return empty, because we don't have any model to query customer request against or the user's request against. So const user message chat message role as user and content as input, then set messages, and we just preserve the message previous, and user message, and finally we set the input as empty. So we set our messages, we set the input empty, and then we need to go on the channel. So here we'll just create a channel, Tauri channel, new channel, actually IPSC channel, and type as chat response. So channel dot on message data as chat response, const message content that we extract, and we get our message. Then we'll just do is set messages, and right here we do is previous. So what we do here is const last message, because we are streaming our response from the Rust code, so we have to update last message. So previous dot length -1, and if last message is not an empty message and the role is assistant, then we want to do is return previous dot slice and replace with role as assistant and content as last message dot content plus message content. So now you get, because we are streaming our response, so we want to always update that message, which is what we are getting from our UI or from our Rust code. And then we'll just have is return previous and role as, if that's not the case, if we don't have any last message which is an assistant message, then we'll always add. Additionally, you can also disable the UI when you are receiving any output, but I'll just stick with, this way. So we have our on input as well. So now, by the way, you can ignore these previous highlight error. It's just from my LSP, but nothing wrong here. We are completely fine as we code along. So now right here, we will have try just after this channel on message. And remember, it is still part of your send message. So right here, we will just await invoke chat. And right here, we'll have request as model as selected model, and messages as messages. Right, go up here and let's make this messages. So messages and user message, which is the latest message. So we send it, and on stream you can set to channel, and right here we'll have catch error console.error failed to send chat message. So once we are failed to send, we'll just say set messages previous, and right here we'll just do is previous role as assistant and content as error could not get response, let's say. So that's pretty much all that we need here. Now let's add a few handlers. So one that we need is handle input change event HTML input element void and set input e.target.value. Similarly, const handle selected change or select change, you can name it, event and HTML input element void. Right here we just forget this thing, and another straightforward set selected model e.target.value. So we have our couple of handles as well that we need, and the final thing that we need is basically the UI, the divs. So right here, div, and class name as chat container, and div class name as chat messages, and then we just iterate over our messages, map message index, and right here we'll just do is div and key as index and class name as message dot this message that we have dot role, and we just pass the role, so message and role, and once we have that we'll just add span and right here we'll have class name as message label, and again message label, we'll just get whatever the role is. So we can also have our own logic, like you or AI, or we can have our logic around, but I'll just stick with message role. So whatever the role is, that's what the label is. And the final thing that we need is, you guessed it right, it's the content. So class name as message content and message.content. So we have our divs, we have our basic UI of chat messages, and then we have a form with, again, straightforward class name as chat controls, and on submit we'll call our send message, and div, pretty basic UI, but enough for our playground to get started before we add more functionalities. Selector inline, so that's our model selector, label and label. So right here we'll add is HTML for inline model select and model. Then we have our select, and right here we'll have a few things to pass. ID as inline model select and value as selected model, and on change we'll just call our handle select change, handle select change, and then we'll just do is models dot map model, and right here we'll just render our option, key is equals to model, value is equals to model, and model. So that's our select, and the final thing that we need is our button, the action. So right here we'll just add class name as input actions and input, and type as text. This is basically where the user can type the message. Value as input. On change, we want to handle input change, and then the placeholder, just for some fancy stuff, type your message, and class name as chat input. And the final thing that we need is a button. So button, and type as submit, class name as send button, and name as send. That's pretty much all that we need right here. So if we scroll down, there is one error here, which is kind of a mistake that we did. Scroll all the way top, and as you can see, we are using HTML input element for both, but here we have to use HTML select element. So let's quickly edit HTML select, and now we go, and as you can see, the error is disappeared. And on top we'll just import our CSS. So chat component.css. Now first of all, move to our app.css and let's add some CSS here. So I just paused and quickly add the CSS because it's pretty basic, and I'll drop the link in the description to my assets in my Git repo. You guys can just copy the same styling if you need. You'll find both for app.tsx, and also we have chat component CSS, so you'll find both. I have added it. It's pretty straightforward and no point wasting time on writing CSS. You guys can also copy and use my CSS, which I already have written once. And if you are just wondering why don't I use Tailwind CSS, because personally I don't like it. It just kind of makes your component looks very terrible because it's most of inline stuff there. So maybe we'll do it in some other video, but for now I'm using this old school style CSS where you have a separate .css file. So make sure you can copy it and use it. So we are pretty much ready for our first demo. One final step before we run our application would be to run some models on your machine. So we'll be using Ollama for that. Now, if you are new to LLMs and don't know how to run models on your machine, there's a video popping on right top. Make sure to click it, watch it. But if you already know how to work with Ollama, just do Ollama ls, and you can see a couple of models that I have on my machine. So if you don't have any models, just do Ollama run llama 3.2 1b or any other model that you want to run from the Ollama repository, link in the description. So now we'll just run our application with yarn Tauri dev, as simple as that. Okay, I see an error here. We have made some mistakes, so let's move to librs, and right here we have get models. Oh, we just forgot to use it. So chat and everything else looks good. Let's write it out. It should automatically rebuild. Here you go, the first look of our LLM playground looks nice and clean. We have our window for messaging, then we have our models. We can pick and choose between Gamma and Llama 3.2, which we have right now on our machine, and then we have a text box to type our query. So let's use our assistant. Just let's say a hi, and then let's say, can you write an essay of 200 words on AI? And there you go. We are getting our response as a stream. And let's use Llama 3.2 1B. And right here we say, hello, I am a user. Can you tell me what is Python? Anything that you want to ask. So there you go. You get your response, and it's pretty fast as well, depending on your machine. So you can query pretty much everything. Probably I'll continue in some future video on this where we'll build more on top of this. But for now, that's it. I hope you guys learned something new. If you do, like the video, share with your friends. I'll catch you guys in another video with another interesting topic. Until then,